Awesome. Thanks, Greg. And thank you, everybody, for logging on tonight. I hope I get to get you interested in this topic. And if there is an occasional slide on cheese, I feel I have to explain myself now. This was from droidCon Berlin, where we had a sort of improv session thing. And one of my topics was, well, the topic I was given was cheese. It was quite difficult to come up with improvisation, so I ended up then repurposing my talk to then cover a lot of topics of cheese because I felt I had to make that up. It was very entertaining, but you might not understand if you have that context. Anyway, so let's move on to the topic at hand. So this is a talk on the navigation library from Jetpack, and it's sort of my experience coming from a situation where I would absolutely hate fragments. Anytime I would join a new project and there were fragments in use, I would automatically convert them to activities and I would just annihilate them on site due to obviously the often disliked methods in fragments and the very confusing life cycle and a lot of the confusion things that's going on here. But then after adopting the Jetpack library navigation library, I felt that actually they had a renewed purpose, and their original purpose actually then I went back to look at. And actually, it was a really interesting journey. It was a really interesting experience. So I'd like to share that with you today. So yeah, comes from my skepticism on fragments and generally everyone's dislike of fragments. So let's start. So what are we trying to solve here? What problem are we trying to solve? So navigation is hard. And it's probably a bit of a misnomer to start a talk on navigation by saying navigation is hard. You're obviously all aware of that. That's why you're here looking at a talk about navigation. But it's often a topic of confusion, and it's like really difficult amongst new developers who are trying to get used to the Android framework, or if they're even just coming from another framework. And it's such a simple concept, really. You wouldn't think it should be something difficult. You are basically navigating from one screen to the next. And this sort of user flow should be intrinsic to your application journey and your user experience. So this fundamental behavior shouldn't be hard, right? So why exactly is this hard? We're just moving from one activity to the next. What makes navigation so confusing? Well, it sort of comes down to Android's framework components. And they are things like activities, content providers, services, broadcast receivers, fragments, anything that is controlled by the Android framework. And this is because of having to handle configuration change or orientation change. This is where you might rotate the device or the keyboard comes into play, or you split screen, or any of these nice foldable devices that are coming out now. And this means that the Android subsystem has to actually completely tear down your instance and then recreate it. So you have to have a mechanism of restoring state, and it has to have a mechanism where the actual infrastructure itself can control the orchestration of these individual elements. So it's not actually you navigating, it's Android, and you are just passing off the command or the instruction to Android to then do so. So in its simplest form, you might have an activity that looks like this. You might create an intent. An intent says, I want to go to this next activity, and then you pass this intent to the Android system. Now here you can see it might look a bit straightforward at first, but actually there's this is not going to scale very well at all. So for a start, we've got the serialization of additional parameters where the name or the key is being used from another activity. So then you've got this activity that knows about the next one and the next one that knows about the previous one, and who is responsible for serialization of the parameters, who is responsible for deserialization, how can you guarantee that the next screen will have the necessary arguments that it needs to show the information. So it's really difficult to maintain this, and especially so when your application starts growing in size. Now, this is sort of kind of bred from the fact that the Android toolkit team don't necessarily have a strong opinion about how you architect or build your application. There's a really well-known quote from Dan Hackborn in 2016, back when Google Plus was a thing, that once you've gotten to the entry point of your activity, of your UI, sorry, we really don't care how you organize the flow inside. And this meant that we had a lot of different things popping up, like Mortar and Flow, and having custom views and having custom things that would actually sort of architect their own architecture because, well, they didn't like fragments. But let's just jump back and look at fragments. So introduced in Honeycomb, API version 14, fragments were intended to sort of break up the screen into individual, more richer interactive user interfaces. And this is sort of the beginning of design-oriented thinking from Google on Android. It was really like a stepping point. And you can think about the original tablet layout where you had the master detail interface. Sorry, I'm trying not to use the word master. The main and detail interface. And this would have like a responsive layout for larger screens. So the idea would be that if you had this layout for your tablet, it would safely change into that of the mobile screen. So on the mobile screen, you might have a list, whereas a tablet, you have a detail of the list that you're seeing on the side. And this was a nice idea because it meant that you have the same layout, the same idea, the same user experience, and then a different screen factor. But the implementation, of course, as per usual, wasn't quite what we had expected, and the promise was a little bit oversold. It was promised to also run properly on smaller screen devices, but not necessarily always would. So this is how you might use a fragment in a simple activity. This is just a sample from the Android source code, from the Android documentation. It's not yet using Kotlin, it's just using Java. Sort of intentional to show you how verbose it is, but here you can see where the fragments are being created, the arguments are being assigned to it, and then it's being added to a transaction. Now, this is necessary for all sorts of reasons because you had to have the flexibility of how to use fragments, whether to have them retained, whether to have multiple transactions, and there's this crossover in life cycle where the activity might be in a different state that the fragment expects. So you have to have maybe commit allowing state loss or something. Furthermore, you have an issue where if your fragment is retained, or if it's actually you've not got it set up correctly, you'll actually end up having it doubly created. So you don't want to actually do anything if the saved instance state is not actually null. If the saved instance state is null, this is representation of our previous state that came before the configuration change. So if this is not null, we know that the activity has already been created. We just need to react to the orientation change. So yeah, as I mentioned, it's important to remember that the activity lifecycle is not the same as the fragment lifecycle. And furthermore, the fragment lifecycle is not the same as the view lifecycle. So we have three sets of lifecycles, and we have to then think about how they interact with each other. Now, this is really great cheat sheets from Jose, I cannot pronounce his surname, Ajedika, I won't try again, where you can see how the fragment will interact with its activity based upon its intention. So, if you have a retained fragment against a non-retained fragment, so you can see the differences in which methods are being called. So it's a nice little bit of information here, but the point is that the lifecycle is difficult to manage when you have multiple overlapping life cycles. And it can be a little bit quite hard as well when you're actually using the backstack if you want to go if you're going in particular directions. You might have to explicitly invoke add to backstack if you're manually handling transactions, and it's very easy to mess up your backstack if you're not doing it correctly. And usually when I'm giving this talk on stage, I would ask people if they recognize this sequence of directions. That is, of course, from the Konami cheat code, which is supposed to be an Easter egg, but it seems a bit obvious right now. There's more complications to this when you add things like the support fragment manager and the child fragment manager. The support fragment manager was meant to replace the original fragment management, but then moved it to the support library, which you could package inside your app instead of waiting for the framework to update it. But then you have child fragment manager if you want to use a nested view pager inside of a fragment, because the former can leak context if used inside fragments. I wouldn't expect anybody to know this, and these are the sort of gotchas that can really trip people up. So, you can understand why people dislike fragments so much. And furthermore, the communication between fragments can be really difficult. A lot of people would then use like an event bus to have this funnel of information going between, but then you have to have like a handover between each one, and you have to then know the state of the fragment, if it's been attached, if the activity is resumed. Add to that the fact that we have to serialize and parcelize all of our data so that we can package everything into a bundle. Bundle can be considered something similar to a serialized file. It's a bundle of serialized data, but there are some limitations. It will only support some primitives and anything implementing the parsable interface. And the parsable interface, when you implement it, describes how you would serialize this as a representation in primitives. So that's not cool, not fun to do, and a real pain in the bum. So, what are the options we have? And well, we have, as of 1.10, you can use the fragment factory. Now, this is really nice kind of evolution because it allows you to actually provide a constructor in a fragment in a similar way to they have with view models and a view model factory. We can start to describe how we want to construct our fragments, even though we still have to delegate this responsibility to the Android subsystem. We can then instruct the Android subsystem on how to do these. So these are all pretty compelling arguments against fragments in general, and you can understand why people don't want to use them or would prefer using activities. And as I mentioned, there are options like Mortar and Flow, or there's a new library that Square is working on actually as an evolution of this. Sorry, I'm not sure if it's an evolution, but I know they are working on a new library that's going to be soon. And then of course you have Compose coming up soon as well. But there were some nice reasons to use fragments. Fragments did actually have a real purpose and a real benefit in some circumstances. Some of these were activity capabilities. Now, the problem with activity capabilities is that these were tied to API versions. So you'd need to wait for a new release of the framework before you could actually start using new features. And in a lot of cases, even when used with compatibility, these features couldn't be backported. For example, the shared element transition in API 21. Now, this wasn't actually properly implemented using the app compat, but it provides shims, which are sort of like hacks that make sure that it fails gracefully. So it doesn't crash or it doesn't have any unexpected behavior, but it doesn't have the same shared element transition that you might actually like to have. So whilst compat shims are useful for ensuring app stability, it's not quite the same when what you're going for is a consistent user experience with nice transitions and beautiful graphics. So there was once a native Android fragment, which was however is deprecated in API 28, and fragments are now entirely in the Android X library. And this is great because we can update this inside our application so that the fragment sits within our application. We don't depend on any framework code, so we can use new features straight away. Another very nice feature of fragments is the ability for us to start scoping. Now, I noticed this problem when I was trying to build more complex and highly scaled dagger graphs, that you might want to have a repository scoped to something that lives longer than one screen, but doesn't live for the entire life cycle of the application, because maybe this only counts for 25% of your users, but for those 25% of your users, having cache data or throughout the user experience is actually quite positive. So there's a real need for having a scope that sits somewhere between a single activity and a single view. So as mentioned, sharing between activities is really difficult. You'd have to then you'd be forced using an application, and there's nothing between an activity and an application that you can use or utilize to your advantage to group these things, except when you add children to an activity. So now we have fragments inside an activity that allows us to actually use the activity as this scope that we want to use. And now further with the nav graph, we can actually use a nav graph view model as a scope, which is fantastic, but I'm not going into that because this is an old presentation. So how exactly can we have our cake and eat it? We want to have all the benefits of fragments, but we don't want to suffer with any of the difficulties of using them. We're greedy, we're developers, we want it all. Well, introducing Jetpack. So of course, years ago, Google introduced Jetpack, which allows us to bootstrap Android development. The really nice thing is it sort of provides a lot of opinionated, clean implementations for common problems, because Google will never really wanting to get as opinionated as they are now, because it's up to us as developers. It was up to us as developers to sort of steer the direction of Android into the direction that we wanted it to be going in, and then Google would obviously work to help us with that. But the architectural decisions would generally have to come from us. But after years and years of the community begging Google for some guidelines, they came up with Jetpack to give us an idea about how to get started. It's important to remember that these are not golden rules that you must do these ways. These are simply suggested implementations. You don't have to use them. You can use some of them. You can use partial individual ones. It's entirely what makes sense to you, and you don't need to completely overhaul your application just because there's something new and shiny, even though I do. So what is Jetpack? Jetpack is a set of libraries. It's a plugin with Android Studio and some tooling used to unify and simplify Android navigation. And it handles all the common parts of navigation patterns and easily handling patterns like draw navigation or bottom navigation. It handles all the fragment transactions for you. All the up and back actions are handled correctly. The standardized transition resources, so you can then specify a unified approach to how fragments should come in and out of the screen. There's integration with deep linking and provisions for that. Excuse me. And there are easy navigation patterns to utilize. And finally, my most favorite part of this is type-safe arguments. So to understand why some of these things are quite so important, we have to know the principles of navigation. The principles of navigation are sort of a core set of consistent, intuitive user experience patterns. These are designed, and Jetpack navigation is designed to implement these principles by default. So you don't really have to worry about, is my app compliant to navigation UX? It just will be, which is fantastic. So you have things like the fixed start destination. This stipulates that the flow through your application should be consistent through both the entrance and the exit. So the user can reach a destination and then they can come back up through that same destination, and then the first and last screen pressing the back button. The state should exist as a stack, which is a complement to the previous slide. And it's a representation of the history that the user flow can be reversible and replayable. The idea is that your traversal through the application is similar to that of being in a browser. If you press the back button in a browser, it will do the same thing as it would do in your application. The up and back tasks are basically identical, with the exception of up never exiting your application. So if you reach the top level of navigation, there shouldn't be an up button. The up button will be usually in the toolbar at the top, sometimes combined with a navigation drawer. You won't want to have this on your first screen, but you would want to have a back button, and the back button would exit your application. And finally, that deep links simulate manual navigation. So if a user were to click a deep link from a marketing campaign or an email, or however you might share these links, it would have the same effect as if the user had actually manually navigated to that point. So then you can replay the going back if the user were to tap up or back. So these are really nice things. And the primary ideal of the navigation is to use existing APIs, not inaccessible ones, not APIs that are hidden from us. You might be aware of the .hide annotation that applies to a lot of Android classes that prevent us from using it, or at least make it more difficult. The idea here is that you could have written navigation yourself. Any one of us could have done this, and then you could extend it, you can make changes to it, you can utilize it as much or as little as is necessary for your application, which is fantastic. So as mentioned, it's built from 3 components. This is the tooling. So Android Studio 3.3 introduces the navigation editor. We are actually, in fact, on Android Studio 4.0. So we've been using this for some time now, but it includes a graphical editor to build your application navigation graph. And it's comprised of a few different components. First, the destinations to the left, showing the host in the graph hierarchy. Destinations can be anything, really. They can be an activity, fragment, dialog, or custom view, and you can create your own destinations as you need. Secondly, you have a graph editor. This is a visual representation showing the flow of navigation through your application. And it's a really nice visual representation. And iOS users might be, sorry, iOS developers might be familiar with the storyboarding approach, and this is something similar from this approach. And finally, you have the attributes, which are obviously attributes on each individual destinations that describe how this destination behaves in such ways. So if it has any arguments that are necessary for it to run, if it has any actions where it might go to the next screen, label, identifiers, various things like these. And if, like me, you would prefer to use XML layouts, XML, actually it's built in such a way that the XML is not actually so horrible to look at, and it's quite easy and straightforward. So you can actually write your own. And I much prefer to hand code in XML, even though the visual editor is also quite nice. So as I mentioned, you can have many different destination types. You can have activities, fragments, dialogues, and then you can define your own destinations as is necessary. If you do define your own destinations, you will have to extend navigator with your type, where T is the type. It could be a view or something similar. You provide the destination implementation, and you configure the arguments after inflation, and then you have to augment the nav controller. All of these things are basically providing a set of instructions to navigation about how you want this individual component created. Because you can think about how you might instantiate an activity, how you might instantiate a fragment, how you might instantiate a view. Each of these approaches is different, but if we want to have these as a unified destination, this creation behavior needs to be abstracted into the implementation of a navigator. So this is why you have to come up with it yourself, but as long as you're handling the backstack properly, should be fine. But in most cases, you won't even need to, because fragments are enough. It's important to know as well that this is similar to sort of resource inflation, layout inflation, because navigation is an XML, your navigation graph is an XML document. So it's still subject to the same rules, like lint rules, compile time validation, resource names, and things like this. It inflates the resource at runtime, so there is a possibility, there is a potential for graph errors at runtime if you have bad references. Inflation cost is negligible; it's not really that much of an issue, but you can sometimes get some graph errors if you're in the wrong place. So what I quite like actually about this is that the nav host is not very forgiving when it comes to destination navigation. So if you find yourself in the wrong activity because of a misconfigured graph, and then you try and navigate somewhere else where you shouldn't be allowed, it will actually throw, giving you an idea that, I've probably done this wrong. So the fragment widget actually acts as the host for this. I've noticed my first incorrect slide. So this has actually been changed to the fragment container view, I believe. But this is actually still functional. I think it comes up with a lint error now in Android Studio, so you'll be able to see that. But once you've set up your nav host fragment, this is basically where all of the controlling is going to happen. This is where the nav controller handles navigation between each one of your destinations. It's only compatible with fragments as for the nav host fragment, so you couldn't really use it easily with other ones, but you could still have navigation to and from activities if necessary. What's nice is the lifecycle and configuration and animations are handled automatically, and the hosts host all movement and screens. So each nav host has a controller that allows you to sort of invoke these actions. And this controller is a very simple interface that typically has a few navigate functions. And you can retrieve a nav controller from a few different ways. There are a few different extension functions which are provided to us, one on the fragment and on the view and on the activity. One thing to note is that if you're finding a nav controller from your activity, you have to provide the view ID of the nav host because the activity is then actually higher than your nav host. So it needs to do a little bit more, be a bit more aware of its surroundings. What's nice as well is that you can assign actions to directly to click listeners. You can actually create a navigation click listener with an identifier and then do that. So instead of having this find nav controller.navigate, you can simply just create a listener and set that. Nice little way of doing it. So many of you might be aware of intent filters in Android manifests if you want to create deep links or if you just want to handle well, intent filters. This is obviously a very enjoyable activity. I haven't spoken to a single developer that hasn't told me, I really love creating these intent filters in another manifest. It's one of our favorite things as developers. So what's nice about the navigation component is that it actually can generate deep link intent filters for you, which is really nice because I'm not sure if the sarcasm came across there. You know, these things are quite arduous and tedious to build and design. So if you just link your graph in your manifest, then these things will actually be implemented for you. So you just have your deep link in your navigation graph, defined with the parameters that have to do this. There used to be such a time in which it had to match every parameter exactly, but that has since been resolved. So you can have optional parameters if necessary. I think you can have question parameters as well. I don't think there is a way of having like a catch-all. You have to actually name each parameter, which is a bit of a pain, but generally this is quite nice and it's solving a lot of problems for us. So optional args are available in 2.2.0, but I think this is moot as we are further along than that. So there are two ways of sort of invoking a deep link. You can do so with URL navigation. This is great for app links, so this is like a cooperative behavior where you give a link and then the system asks if something can handle it. And if you set up your navigation graph correctly, it'll say, yes, that's fine. And it'll go to where it should be. And then you have the other type, which is explicit links. And these are built to allow you to programmatically produce a pending intent. And then you can apply a pending intent to something like a notification or a widget or a view click listener. And it might like something like this, where you specify your graph, your destinations, you add your arguments, and then that creates a pending intent. You can execute the pending intent immediately, but I've not had much luck in doing so, as it does, well, the first time I was trying to use it, just didn't make a lot of sense. Turns out I didn't actually use it. I didn't need a deep link explicitly. I could just use the URL. You can also use a nav controller, which will then already know about the host, so that's going to skip that step. And then you can use that to start activities. So cool. There are lots of different navigation styles as well. I mentioned briefly earlier that it has support for bottom navigation and draw navigation. And these are quite common paradigms. So you have things like a toolbar where you might have a contextual variant if something is selected, or you have a bottom navigation drawer that has now since become enshrined in material design. And of course, you have the traditional navigation drawer, which is still historically relevant. So your configuration would basically be just calling setup with nav controller. Now there's a few extension functions available that make it a bit easier to kind of use this, but quite simply, if you had a simple toolbar, you would just say setup with nav controller, the controller, and the draw layout. As I mentioned, there's a few extension functions available where you can then tweak the commands necessary. I recommend checking out the source code for this actually, because it's really interesting and you can see how it delegates through the hierarchy of calling these different extension functions and how you can actually customize it for your own needs. And it comes from this app bar configuration class. Now this app bar configuration class describes the construction on how things should be built and has all the different information about it. Whereas if you're using it with a draw or collapsing toolbar or these things, then it sort of does these for you. But if you want to specify your own, like you may want a custom behavior, then you can do so. You want to design your own top-level destinations. Maybe you don't want to show the back button in certain situations. It's set up for draw layout, which is fine. You can set up a fallback up listener. So if, for example, you need to have some default behavior, you can listen to some destination change listeners. And I know you can use this for any reason, really. I suppose you could have it for logging if you wanted to. I noticed I have a semicolon there. That's foolish. So it's not a closed API. Functionality can be modified or handled specifically as you need. And it's really extensible, and you can really kind of modify it as and when you need and implement your own custom behavior. What's important to remember as well is that in 99% of the situation, sorry, 99% of the time, you won't need Coming back to bundles, and this is probably one of my favorite parts of navigation, is actually this further plugin. Now, we still have to do serialization, but with the SafeArgs plugin, which is part of Navigation Jetpack, it will generate argument classes from your navigation graph, which will have all of the arguments necessary, that have all the destinations necessary, everything that is required to go from one screen to the next will be codified. And the best part about this is that the generated argument class is not only a Kotlin class, it's null safe and provides defaults. Sorry, it's 1 second to close my door. Bit windy outside. You can only use primitives or parsable values, as always with bundles, but this makes it much, much easier when it generates the implementation for you. So the implementation might look like this. It might look like main fragments direction.main to view balance. And this is the name that you defined in your navigation graph, where you're saying the action from one destination to the next, and that's the call you're going to make. And this is the class. This is the thing that SafeArgs will generate. And of course, it won't generate properly if you misconfigure it. So this will break at compilation, not at runtime, which is great. So if we add like a new argument to the view, and then it will update the generated directions class to take an argument now. So now we've added the balance amount. The arg classes will update accordingly. So now we call this main to view balance, and we have to provide this parameter. And what's really nice is because this class is generated automatically for you, as soon as you change your navigation graph, it will then be reflected appropriately. And if you're calling it, and if you're calling it wrong, it simply won't compile. Which is really nice, because otherwise, like previously before this, we might have to then check for the existence of a serialized parameter in an input stream, or have nullable values, or have all these sorts of things where we could potentially just omit something and have something crash at runtime, which is obviously not a very good user experience. The generated class looks a little bit like this, and generated code is never going to be pretty. But generated code is always going to be consistent and reliable, and what's more, it can't be abused. There's no way of sort of changing this code afterwards, so there's no way you can sort of inject behavior and kind of violate any single responsibility principle in it, or kind of have these kind of anti-patterns that we want to try and avoid, which is really nice. So it's just nice having these things available automatically. And serialization has always been a pain, so this feels almost magical coming from a world where you have to do manual serialization. And yeah, so like we can guarantee that serialization will happen correctly, and importantly, deserialization will happen correctly as well. So when we retrieve the parameters, they're going to be in this kind of Kotlin type safe class. The nice thing about this is that it defines a single source of truth. This single source of truth is going to be gospel for your activities. It's not open to interpretation. It can't be modified. It sits isolated from both your caller and your receiver, and it is something that exists on its own, and as I mentioned, can't be modified. Another thing about this as well is that you don't have to go all in with the navigation library to use SafeArgs. You can actually already start using SafeArgs if you only have activities. You can start using the plugin immediately and then utilize these arguments with only activity destinations. You'll have to navigate yourself since you won't be able to use the fragment nav host, but already having this nice argument class generated for you is a real benefit, and it is incredibly useful, and you can delete so much code. I've deleted thousands of lines after introducing this. It's really useful. So how could you migrate using the paging library? Well, carefully. As with any migration, we do so very, very carefully. Because it may be difficult if you're making heavy use of activities. And you probably already have various navigation paradigms in place, in use. So sometimes you might find that they're not so compatible with each other. And you have to be sure that the benefit of migration is going to outweigh the cost here. I can, with reasonable certainty, tell you that it is, but this is a decision that you have to make with your own team and with your own project. I would definitely, absolutely recommend using safe-args for activity arguments. If you do not wish to use the rest of the Jetpack library, sure, but safe-args is, for me, it feels like it's low costs, high benefit. I think it's really worthwhile investigating. So consider perhaps, let's go for an example. Consider the left to be an activity to display a list and the right to show the activity, to show the details of that list. And here, of course, we have the reference to cheese. You might recognize these screenshots from Chris Bain's cheese plate activity, cheese application from some time ago. A bit old now, but still funny. So you want to be able to kind of move behavior away from your activities. If you're already using good modularization patterns, this should already be this shouldn't be a problem for you. You shouldn't already have a lot of logic in your activities. If you're not already using view models, make use of view models and move any behavior or responsibilities away from your activities into your view models, because it's much easier to move a view model from an activity to a fragment than it is to move a behavior from an activity to a fragment. And it's just good practice. So then you can create a new activity to host all of your fragments, and it can be just a frame layout, and it will later become host to navigation graph. And then you move your existing activity logic to your fragments. You change your fragment bindings to activity bindings, on create view to on create. Make sure that you can utilize on view created once things have, if you need to have post view creation behavior. These are things that don't really exist in an activity because you just have a on create and that's it. But here with a fragment, you have extra things to be concerned about. And of course, you're using view lifecycle loader. As mentioned, if you're using view models extensively already, you shouldn't have much logic in your activity anyway. So moving these behaviors over to fragments should be trivial in most cases. And then you can initialize a fragment in the host activity, like so. It's no more difficult than just adding a fragment to your host. You're actually just using the old school fragment transaction here. And then you'll want to pass your arguments as necessary. Here we're creating some intent extras and put it on the cheese list fragment because cheese. And then you can create your navigation graph once you've got this sort of layout of operations. And your navigation graph might look like this. You have these two destinations, fragment 1 and fragment 2, cheese list fragment, cheese detail fragment. You'll want to create your navigation hosts, specifying that the nav graph is this resource and that it is indeed the default nav host. The nice thing about this is when you specify the name navgraph and default nav hosts, again, noting that we shouldn't be using a lowercase fragment here, we should be using fragment container view, you won't have to do anything in your activity. So your activity becomes this really simple, dumb activity with just one layout. And now that we have, argument constructors for activities, you could simply have the layout in the parameter for app compat activity and have your activity defined in one line. Isn't that nice? So then you might want to add an action to navigate from one fragment to the next. I might want to add an argument saying the item ID. So here I'm saying I want to navigate to the details fragment, and the details fragment says I need an item ID to display the things I want to display. So your fragment might look like this. In your view created, that's just setting an adapter. Feel free to ignore this. And then the click callback is where you are listening to this event and you're navigating from the nav controller. And that's it. That's all you need to get started. You can get started using safe-args straight away. You can start migrating things away from your activities and the view models, start using fragments. In our application, it's a very large application, so we have not yet migrated fully to using the navigation library. But it's really straightforward to use the navigation library in individual modules or even just on individual screens and then manage them interoperable with each other. It has great interoperability. They work really nicely with each other, and there's not really a reason to not check it out. Another thing to be aware of though, that a lot of developers question is the presence of activity result or how to handle this. Since fragments do have an on activity result listener, if it was called from a fragment, it's a bit more tricky when you're working with an abstracted navigation pattern. Now, previously, there was only a ticket that we had to star to get some attention, but the team have actually made progress on this and have introduced what they've called the saved state handle. Now, if you check the view on ViewCreated methods and you retrieve the current backstack entry from the nav controller, you can then listen to changes to this value. So once the new fragment calls the equivalent updated backstack entry and updates the value with this, you'll receive an update in this or the original fragment of the new data that has changed. And you can check out the documentation for that over at the Android developers documentation. I'll be showing the slides will be shared at the end as well, so you can check these out as well. There's also a mechanism using live data and event, also a recommendation from Jose. This allows you to safely communicate with your activities. Now, sometimes you can have a problem with fragments or even activities actually, where things have been destroyed and recreated after configuration change, and then they resubscribe to a stream of events from your view model. Now, of course, your view model would have been persisted through its configuration change, and that existing live data value will still be there. So once the fragment or activity has been recreated and then it resubscribes, receives the latest value again, which then says to navigate again. So you might end up in situations where you have two fragments being created when you only wanted one. And this is a mechanism of doing so, of guarding against that. What event will do is allow you to only consume the contents once, and then it would return null after that. There's a lot of arguments about this being not the best pattern or it being an anti-pattern. I would probably recommend the use of a single buffered channel from coroutines as an alternative to this. But this is also a really great approach. And the link is here to Jose's article on where he's explaining its benefits. We also have dynamic features, which dynamic features are installed at runtime, so you can reduce the APK size. This is really, really cool. And we're starting to see support after IDS, but it's still a bit early access. Deep links, safeguards navigation editor in dynamic graphs, not yet supported, unfortunately, but there is more and more coming. I would really like to see safeguards compatible with dynamic features, but I honestly have no idea how that would work. There's also a great talk from Ian Lake, the single activity from years ago, why, when, and how. I would very much recommend checking this out. And then actually kind of checking out the more recent talk from the Android Developer Summit last year, where he covers the content from the previous talk and then speaks about how they want to go in the future. And that is everything from me. Thank you very much, everybody.
Well, Ash, thank you so much again for being back with us today. Hopefully you can hear me.
Yep, I can hear you.
Had a little bit of weird audio problems today, so we've got quite a few questions queued up, and I'm just going to pop out here and let you get to those. We've got about 10 minutes, so make sure just please read the top question. Uli will click that away as soon as you've started answering, and we'll go from there.
Cool. Okay, so how does Jetpack navigation handle bottom navigation with potential multiple stacks? Also, are there docs on the correct way to handle back press with bottom navigation? In regard to the documentation on the correct way to handle back press, I would probably say this is similar to the principles of navigation. This is well documented on the navigation on the Jetpack website, where it says how up should behave. But I guess it's not necessarily on the implementation, it's more about the theoretical user experience. In terms of the bottom navigation, I'm not exactly sure how to implement it for your use case, but I do know that it is extensible and you can provide your own options to customize the behavior as you need it. As I mentioned, the fragment library is built in such a way that it is extensible and you can use as much or as little as you need. So you will be able to always have your behavior that you need. Thanks for the question. Next question. In my activity, I have bottom navigation inside which there are my fragments. There are some fragments which shouldn't have bottom navigation. How to implement it? A lot of people using bottom navigation. So I'm not sure I understand the question properly. You have fragments inside your bottom navigation. I probably wouldn't include fragments there. Maybe that's not what you meant. But yeah, I'm sorry. I'm not sure I understand the question properly. Is this actually, rather than stumbling, please feel free to contact me on Twitter, and I'd be happy to have a further discussion about it, and I can maybe better understand where the information you'd like to know. Sorry I couldn't answer that properly. I'll do my best to do that on Twitter. So next question. Oh, this just changed. Okay. Does everything should be on navigation? Sometimes we have a screen, maybe an activity that is independent from where it comes and has no navigation from it. Absolutely. Sorry, absolutely not. Sorry. You can use navigation as much or as little as you want. You do not have to change everything to be navigation. Of course, everything works nicely with each other when it is all on the same platform, on the same library. But there is absolutely nothing stopping you from having one screen, an activity somewhere, and then having that integrate with your navigation graph. Your navigation graph can still use your existing elements, and you could actually start using navigation today and just define your existing activities as destinations. So there's absolutely no restriction here. You should be able to do that without a problem. How does Jetpack navigation handle bottom navigation with fragments loaded using dynamic feature modules? Wow. I don't know. Good question. What I can tell you is that the team will have likely provided an option for this, but I think since dynamic features, there's a lot of complications, a lot of difficulties with how it sort of loads everything at runtime, that it makes it very difficult to use with these types of things. So you sort of have to, these dynamic features exist in isolation without the rest of the application really knowing about it. So I would probably hazard saying that this is maybe not possible or maybe not kind of, feasible in its current state. But I would have to look into that further. Thanks for the question. It's actually really good. But again, sorry. Does Jetpack navigation scale well with larger projects? Yes, it does. So I'm using navigation in my current project with Immobilian Scouts. Our project's been around for about 10 years. It is a humongous project. And whilst navigation is not used in all modules, I have navigation used in a lot of different ones with some very large navigation graphs. It is very scalable. In fact, that's actually one of the most important factors of it, is that it is scalable. Some of the really nice features actually started presenting themselves once people started using them from the entire application. This idea that you could use a single activity for the entire application meant that you would have to then have something in between a fragment and an activity if you needed some sort of store there. And that's why you can use your navigation graph as a store for your view model. So you can retrieve a view model from a navigation graph. Then since you can have nested navigation graphs, your entire application hierarchy is defined in a navigation graph. And at that point, the activity sort of becomes a bit redundant. That's a really nice feature. So absolutely, it's definitely scalable. Next question. Navigation with back button and nav drawer. There are a lot of issues around them. Any resources for good implementation that takes care of all the cases? I think actually it should handle this out of the box. So if you set up your nav graph properly with a back button, sorry, with the navigation drawer, the back button should behave as appropriate, coming back through the hierarchy until it reaches the top and then exiting your application. As mentioned, the principles of navigation is obviously a good source of documentation for this, so you know how it should theoretically behave. But with regards to the implementation, I would, wherever possible, delegate this to the fragments library. Next question. It's possible to manage multiple navigation graphs in one app. If so, it gets merged when app is distributed like app bundles. Okay, yes, it is absolutely possible to manage multiple navigation graphs in one app. They are not merged as such. They are sort of contained. You have to remember that these are resources. So much like having a layout file or a drawable resource, these are going to be treated in the same way in that they're inflated at runtime. So you can define nested graphs, you can define graphs in one module and then have another module depend on that and then import that graph. And when that graph has been imported from the other module, it'd be as though you copy pasted it, and the behavior is exactly as you expect it should be. So this allows you to actually maintain this level of modularization in a well-architected app, while still benefiting from having things like safe arcs, well-documented navigation graph. Cool. Next question. I've experienced that going to another fragment makes a replace fragment by default. Is there a way to override and add instead of replace? I believe this is actually highlighted in an issue on the issue tracker for this library. And if memory serves, I think Ian had said that this was actually the intentional behavior. It would be possible to override your navigation. I think there was some other edge cases where people wanted like a transparent dialogue and you needed a sort of different behavior with the fragment. It is entirely possible just to copy paste the fragment navigator implementation and tweak it for your own purposes. It's a bit arduous to do that because it's not a small implementation, but that's how you would do that, or how you could do that. How to deep link to a fragment inside a fragmentception. Quite simply, actually. So it's important to remember that the navigation library treats every destination as a destination. It doesn't care whether it's an activity or a fragment or a view. So if you have defined your deep links in your navigation graph for one particular fragment and you provide that as a URL or as a pending intent to the user, then it's just going to handle it as expected. It doesn't matter whether you're in a fragment or in an activity. It will properly navigate from one to the other. So you shouldn't have problems with that one. Can we navigate to fragments in different Gradle modules, or do we need an activity in each module with a separate graph? Yeah, I touched on this one a little bit as well. You absolutely can. Navigation graphs can exist in different modules and you can navigate between them. You can import one navigation graph from one module into another one if you have the activity there. What you might find, however, is, as you mentioned with the activity per module, if there isn't a host to go to that lives in a higher domain as such, like if you don't have a single activity in your application module, in the root module, then you might need to have an activity per module just so there's like a landing activity. But if each one of these activities is really dumb, the further you get through the implementation and the migration to navigation, you'll find that it's really easy just to sort of collapse these over time, and you can then start moving towards this truly single activity. Cool. Can we navigate to fragments in different Gradle? Well, that was the same question, sorry. In the navigation editor, I get preview unavailable, even though I use tools.context in my layouts. Any idea why? I'm afraid it can be for any number of reasons, unfortunately. It could be a misconfigured graph. It could be just an unstable version of Android Studio. What I would recommend doing is probably make sure you're using the stable version of Android Studio, which as at this moment is 4.0. And then maybe try checking out the sample repositories from the Android samples GitHub repository, and then you can check out some nav graphs there, and then make sure that they appear properly in your IDE. Maybe you could copy paste them over and then try them in your project, and then see if they are showing in the layout editor in the design view properly, and then sort of try and debug it through that. Just process of elimination, remove part by part. Next question.
Ash, let's have you answer one more question. I don't want to cut Davies short, but we want to make sure that we give her enough time. So let's do, you can choose any of these four that are there, choose your favorite question, and that'll be the last one for the day.
You know what, actually, I'm thanking you for this because I see we have another 13 questions. All right, so let me have a quick read of these.
They're all going to be posted to your private.
Aha. I'm going to go with Gavi's question, the third one, because this is actually quite interesting. Live data unchanged is called every time I come back to a fragment for a method called consider notify. Consider notify is the implementation that goes on behind the scenes in live data, and it's where it says, consider notify checks if there are any subscribers on the live data and whether those are in the right lifecycle state, and then it decides on whether to then inform or call this on change function in your live data. So that's just where it shows in the backstack. Now, the reason this is happening is because when you come back to your fragments, it is then being resumed. Maybe it was resumed after a configuration change, maybe you navigate from somewhere else, and then you're collecting these events from your view model. But the problem is that the view model was retained through the orientation change. So it's the same view model, and live data is a sort of data holder. So when your fragment then resubscribes to the live data on your view model, it will then receive the latest event. This is known as conflation. No, so yeah, kind of. And this means that it will receive the same indication that it should navigate again. So it will then try and navigate twice when probably not what you wanted to do. The best way to resolve this is you can wrap the data type of your live data inside the event. This is the event class that I mentioned in a few slides earlier. The links will be shared online, which makes sure that the event can only be consumed once, and then once it's consumed, it doesn't allow it to be consumed again, making sure that your fragment will only navigate once. You can use an alternative approach from coroutines, where you have a channel with a buffer of 1 or a completed channel, and then consume it as a flow. Make sure you use receive as flow, not consume as flow, otherwise the upstream channel will be terminated. So I hope that answers your questions, and I hope you've all enjoyed the presentation. Thank you.